Assalamualaikum everyone and a very good day to all. This video is based on the second chapter, that is the network models. This chapter is the preparation for the rest of the course. In this chapter, we shall learn the idea of network models in general and protocol layering in the OSI model and TCP/IP protocol suite. Here is the table of contents for you to navigate through this video. These are the learning objectives to be obtained after you went through this video. You can check them yourself whether you have acquired the objectives or not. So in this video, we will look at the need of protocol layering, the two principles behind it in two examples, that is TCP/IP and OSI model. And in this particular video, we will only look at the protocol layering, and I will continue on the examples of TCP/IP and OSI model layering in the next videos. I hope you still remember what does protocol means from chapter 1. A protocol defines the rules that govern both the sender and receiver and all intermediate devices, and they need to follow in order to be able to communicate effectively. When communication is simple, we may need only one simple protocol. When the communication is complex, we need a protocol at each layer or protocol layering. Okay, let us develop two simple scenarios to better understand why do we need protocol layering. In this figure, this is the first scenario. We can see that the communications is simple and it can occur in only one layer. So this is an example of a single layer protocol. So let's assume Maria and Anne are roommates with a lot of common interests. Communication between Maria and Anne takes place in one layer, meaning face-to-face and in the same language, and it is very simple. Okay, even though this is a simple scenario, there is still a set of rules that need to be followed. For example, they should greet each other when they meet, and they should be aware of their vocabulary level or the limitation according to their friendship. I mean, if they are close friend, then perhaps more informal, and they can joke around and while discussing. And then Maria and Anne know that they should refrain from speaking when the other person is speaking. They should speak in turn and not speak simultaneously, otherwise you wouldn't understand. And each party knows that the conversation should be a dialogue, not a monologue, meaning that they both should have the opportunity to talk about whatever topic they are discussing, and they should also exchange some nice words when they leave, like talk to you later or bye and so on. Let's see the second scenario. In this second scenario, we will see the communication between Maria and Anne takes place in three layers. Okay, so this can also be known as three-layer protocol. Okay, let's go back to the assumption. Before in the first scenario, the simple communication, and Maria are roommates. Perhaps they are studying undergraduate studies, and now they already graduated and have to move out and no longer roommates. Okay, so in the second scenario, the two friends still want to continue their communication and exchange ideas because they have come up with an innovative project that they want to start a new business during their spare time. And then they decide to continue the conversation using regular mail through the post office. However, they do not want their ideas to be revealed by other people if the letters are intercepted. So they agree on encryption-decryption technique. The sender of the letter encrypts to make it unreadable by an intruder. The receiver of the letter decrypts it to get the original letter. Okay, so these are the three layers. So we can see them bit by bit, all right? Let's say before that, we assume another thing is that Anne and Maria each have three machines or robots that can perform the task at each layer. Okay, let us assume that Maria sends the first letter to Anne. Okay, so Maria talks to the machine at the third layer as though the machine is Anne and is listening to her. The third layer machine listens to what Maria says and creates the plain text. Okay, basically it's a letter which is passed to the second layer machine. So the second layer machine takes the plain text, encrypts it, and creates the ciphertext, which is passed to the first layer machine. The first layer machine, presumably a robot, okay, takes the ciphertext, puts it in an envelope, adds the sender and receiver addresses, and mails it. Okay, so at the receiver side, at N side, the first layer machine picks up the letter from N's mailbox, recognizing the letter from Maria by the sender address. So the machine takes out the ciphertext from the envelope and delivers it to the second layer machine. The second layer machine decrypts the message, creates the plain text, and passes the plain text to the third layer machine. So now the third layer machine takes the plain text and reads it as though Maria is speaking. So here we can see the protocol layering enables us to divide complex tasks into several smaller and simpler tasks. Okay, so one can argue that having a single layer makes the job easier. There's no need for each layer to provide a service to the upper layer and give service to the lower layer. For example, they could have just used one machine to do the job for all three machines. However, if Maria and Anne decide that the decryption done by the machine is not enough to protect their secrecy, or they found out that their code has been broken, they would have to change the whole machine. Okay, so but in this in the present situation, in the three-layer protocol, okay, they only need to change only the second layer machine. The other two can remain the same, and this is referred to as modularity. Okay, modularity is, in this case, means independent layers. A layer or a module can be defined as a black box with inputs and outputs without concern about how inputs are changed to outputs. Okay, so if two machines provide the same outputs when given the same inputs, they can replace each other. For example, Anne and Maria can buy the second layer machine from two different manufacturers as long as the two machines create the same ciphertext from the same plain text and vice versa. They do the job. Look at the advantages of protocol layering. Okay. One, it breaks down complex problems into manageable components. Two, implementation details of one layer are abstracted away from other layers, or in other words, it is that the details are intentionally concealed in order to simplify things conceptually, meaning that it allows us to separate the services from the implementation. A layer needs to be able to receive a set of services from the lower layer and to give the services to the upper layer, and we don't care about how the layer is implemented. For example, Maria may decide not to buy the machine or the robot for the first layer, and she would do the job herself. Okay, as long as Maria can do the task provided by the first layer in both directions, the communication system works. And another advantage of protocol layering, which cannot be seen in our simple examples, but we can discuss it, like for example, in protocol layering in the internet. Okay, we will see later. And then the third, the communication does not always use only two-end system. Okay, that means that there are intermediate systems that need only some layers but not all layers. Okay, if we did not use protocol layering, then we would have to make each intermediate system as complex as the end system, which makes the whole system more expensive. Okay, and let's look at the disadvantages. Okay, well, we can have data overhead because of the appending of multiple headers to the data. And another possible disadvantage is that there must be at least one protocol standard per layer. So with more layers accumulatively, it will take longer time to develop and process the standards. So processing overhead due to many layers are invoked to move data from application through the communications software. Okay. So to conclude, we have two principles in protocol layering. The first one dictates that if we want bidirectional communication, we need to make each layer so that it is able to perform two opposite tasks, one in each direction. For example, in the previous scenario, the third layer task is to listen in one direction and talk in the other direction. So the second layer needs to be able to encrypt and decrypt, whereas the first layer needs to send and receive mail. So these are the two opposite tasks and one in each direction. So this is for bidirectional communication. The second principle is that we need to follow in protocol layering is that the two objects under each layer at both sides should be identical. For example, the object under layer 3 at both sides should be a plain text letter, and object under layer 2 at both sides should be ciphertext letter, and the object under layer 1 at both sides should be piece of mail. Okay, so the second principles require two objects should be identical. Okay, next we go to what is logical connections. Okay, with layer-to-layer communication, there is a logical, or in other words, imaginary connection at each layer through which they can send the object created from that layer. Okay, so the concept of logical connection will help us better understand the task of layering we encounter in data communication and networking. Okay, when you talk about logical connection, the opposite to it is physical connection. So a physical connection in networking is how devices are actually plugged into each other, how they're connected to each other physically. And a logical connection is how the data moves between the devices according to the connection just now. Okay, of course, the logical connection is made using the physical connection, but perhaps we can use this analogy if, like for example, all the street and highways, okay, that is the physical connection, and you driving the car making a logical connection from A to point B. Okay, basically logical connections helps us visualize the data flow as the path a packet takes can always be represented by a physical network diagram. Okay. Let's see this example. So we can see that the logical connection between each layer as shown in this figure, which means we have layer to layer communication. Maria and Anne can think that there's a logical or imaginary connection at each layer through which they can send the object created from that layer. Okay. Before I end this video, please let me know how is your understanding on this topic throughout this video so far at this link. Your participation is highly appreciated. If you have any questions or comments, please let me know. Thank you and see you on the next video.